Since Halloween is slowly approaching, I've been thinking about what kind of Halloween-related electronics project I should build. After spending the last 2 Halloween episodes perfecting an ultrasonic mist maker. And then, out of the blue, I realized that ultrasonic mist makers are not the only way to create mists, or fog, or smoke, or however you want to call it. There also exist commercial fog machines that use so-called, and I'm not joking here, fog juice, in order to create smoke. But what does it take to turn such fog juice into proper smoke? How does it work, and can we even build a simple smoke machine on our own? Let's find out. This video is sponsored by JLC PCB, where you can get very good quality PCBs for as low as $2. So upload your Gerber files today and get your own PCBs due to the fast delivery time within a week. First off, let's find out what exactly this fog juice is. After a bit of high professional research, it seems like fog juice is a mixture of glycol and distilled water. This mixture comes with an evaporating temperature of around 200 degrees Celsius, at which point it becomes the desired smoke. Most importantly though, it is only toxic if you swallow it directly, but aside from that it is not listed as a hazardous product. So with the basics of fog juice out of the way, I sucked a bit of it up with a pipette in order to drip it onto my 350 degrees Celsius hot soldering iron to create smoke. Needless to say, while this method shows us that the fog juice works as expected, it is certainly not a smoke machine. The magic component which could do that is such a fog machine pump. It not only sucks up the fog juice, but also presses it into a heated up chamber where the fluid turns into vapor. Now, I didn't feel like ordering such a pump though, because not only would it have taken forever to ship, and mains voltage can be quite dangerous, but also because I've had these packages with Nichrome Wire lying around that I wanted to use for quite a while. As the name would suggest, it is an alloy of nickel and chromium, which not only comes with a high mechanical strength, but also with a melting point of around 1400 degrees Celsius. Which means it could easily withstand the evaporating temperature of fog juice. To achieve such a temperature, we can utilize the rather high resistance of the wire. As an example, I will be using this 0.2 mm thick Nichrome wire, of which a 10 cm long piece features a resistance of around 3.6 ohm. That means by applying, for example, 5 volt to the wire piece, we should get a current flow of 1.39 amps, and thus a heating power of 6.95 watts. So I tried just that, which worked as expected, and rose the temperature of the wire above 200 degrees Celsius, which was enough to vaporize the fog juice. Awesome! And by increasing the voltage even more, the wire started to glow and eventually broke apart at a hot spot, which we definitely want to avoid for our fog machine. So now that we know that Nichrome wire is suitable to evaporate fog juice, how should we bring them in contact? To answer that question, I firstly 3D printed a small container, which I filled up with fog juice. Of course, an idea like submerging the Nichrome wire does not work, since even though the wire shines bright orange before submersion, it gives off its thermal energy to the surrounding liquid rather quickly. It basically acts more like a kettle at this point. My first real idea was to create a spring-like shape and then letting a motor pour fog juice over it in order to vaporize it. And as you can see, creating the spring shape was no problem at all. But after trying to pour fog juice over the heated up wire, I noticed that it slipped off it instead of vaporizing, which means that this idea was not good enough. It got me thinking though that I would need a material which not only holds the fog juice, but is also capable of having the hot nichrome wire wrapped around it so that it can reach the evaporating temperature. The magic component I'm talking about is of course a propane lamp wick. For our first test, I cut off a small piece, wrapped wire around its upper section and submerged it into fog juice before standing it up straight and powering the wire. And as you can see, it does kind of work. I said kind of because the high temperature also created burn marks, which we definitely want to avoid. That is why I experimented a bit longer with all my given materials to finally come to a design which creates the smoke more or less reliably and without burn marks. The solution is to use 5 to 6 turns of 0.2mm wire around 1 or 2 wicks, while the wire should only be positioned close to the surface of the liquids. And with this proof of concept in mind, I started creating not only a blueprint on paper, but also 2 3D models for my mini fog machine. After 3D printing them with orange Plusament PETG filaments, it was time to mount all the necessary components to them. So I started with the big hole in the top piece of the machine, which is for an 80mm fan whose mounting holes I had to drill before I was able to secure it to the 3D print. Its job is to create a breeze which pushes out the smoke through the smaller front-facing escape hole. For the bottom piece, I firstly had to mount this water level sensor on the inside, which creates a variable voltage depending on how much liquid is still left in the container. If the fog juice level is too low, the Arduino, aka the heart of the system, will notice that and deactivate the heater. The heater, by the way, as well as the fan, is power controlled by 2 MOSFETs, which on the other hand are controlled by the Arduino through ports with modulation. And of course, as an input, I use 2 potentiometers to set the fan speed and heater temperature according to the changing duty cycle of the PWM signals. So according to this simple schematic, I created the smoke control circuit around an Arduino Nano onto a piece of perf board. And as soon as that was finished, I uploaded a very easy to understand piece of code onto it. After then mounting the circuit to the side of the bottom piece and connecting the water level sensor as well as the fan, it was time to build the heater. I built it just like I described it earlier and then continued by hot gluing it into its own little 3D printed indentation. After then screwing in 2 M5 bolts next to it, which I used to mechanically connect the nichrome wire to copper wire, as well as giving the whole construction a bit of support, it was finally time to hook the heater up to the electronics, pouring the fog juice in, closing everything up and powering the system. And as you can see, my idea of a crude, minimalistic fog machine did work. But since we are dealing with high temperatures here, and I read online that there's a possibility to somehow create toxic fumes, I highly recommend that you do not build my version of this machine, and instead go for a cheap commercial one. But nevertheless, I hope that you got into a spooky mood through my electronics creation. If so, don't forget to like, share, subscribe and hitting the notification bell. Stay creative, and I will see you next time!